2024 has been insane for artificial intelligence. I am finding models that are so unique and they're applied to such interesting areas and nobody ever covers them. So I'm going to try to squeeze them all together into this video. First off, I'm going to talk about how archaeologists have started using AI to identify really old items. So this paper talks about a tool that was built for archaeologists to date bronze dings. Yeah, and I know bronze dings kind of sounded like a joke for me at the beginning. Like, what do you mean bronze dings? Like, would you identify a ding? But that's actually a thing archaeologists do. Yeah, so a bronze ding, that's actually a ritual vessel that's used for cooking and serving food offerings in ancient China that people sometimes dig up and need to date. So if you dig up one of these bronze dings, you might think, oh, like, was this used during the Shang, the Zhao, the Qin, or the Han period? Psh, AI's got you covered. So some archaeologists dug up, no pun intended, a bunch of data about ding images, and then they annotated those images with the periods and the features that experts knew about, and then they let this AI get trained on that data. Now boom, like taking out an iPhone app, you just dig up one of those bronze dings and it tells you what era it came from and a whole bunch of other interesting information. But what I think is kind of cool about this is even though it was built by archaeologists for archaeologists, of course, when you build something like this and you just put it in the App Store, in this case it was the WeChat mini program, a lot of regular people can all of a sudden sort of become archaeologists. Like they start finding really interesting ways to use it. They start teaching the archaeology community about things that they're finding. And I just thought that was really cool. As I dug into this Ding program, it turns out a lot of regular people got really into it and started kind of without commercial intent studying and educating people in the field, and it became a strong community around like a cool science. But it's also cyclical. Like those images are also training those models because they're open source to be better. So when you take a photo of a ding and it goes up to an archive and real archaeologists look at it and start noticing patterns or they find things that are mislabeled, they can update that. The model gets smarter. You know, I suppose that the archaeologists could also reach out to the person who took the photo. They have the account and email them and say, hey, I saw you found a really cool ding. I would actually like to study that or see that, or could you mail that to me, or could I visit you? Like, what about people if they're in the ocean and they identify things, maybe hobbyists that could like work with oceanographers, or any other branch of like science or geology where just people can get more involved with the scientific community. All right, next up, let's talk about this paper, Deep Learning Models for Automated Classification of Dog Emotional States from Facial Expressions. That's dog facial expressions. Now we know a lot of AI facial recognition is being used in like Walgreens and grocery stores and border crossings and all sorts of stuff like that for humans. But some researchers put a paper together and they applied the same science, but not to the face of a human, to a face of a dog, right? Dogs have all sorts of emotions just like us. They become happy, they become frustrated, they become scared, and there's micro tells in their ears and their eyes. I mean, not even micro tells, like honestly, we all know like what a dog's feeling. They're pretty expressive, especially since they're man's best friend and we bred them from wolves to be our friends. They're actually super expressive, specifically because we bred them to be expressive. But point is, now AI knows that knowledge in the same way we do. So the architecture that these researchers used was ResNet and a vision transformer, and then they compared the effectiveness of recognizing the dog emotion from facial expressions to what the people thought they were, and they were able to build a model that does just that. So I don't know, like maybe this will become more and more refined to the point where you can like point your iPhone or something in the future at your dog and it can look up at you and it will say, like hungry, scared, worried, maybe something more nuanced that we wouldn't see over time would emerge. And what's interesting about this paper to me is that there is no real ground truth because you can't exactly ask a dog to fill out its emotions and tell you what its facial expression correlates to. So the complexity is establishing the ground truth in a non-verbal species. So there's a bunch of extra things they had to do. It's not just a human's opinion of what the emotion is, although that's where it starts. There's also controlled experiments, which have opened up new insights into how we can get the sense for what a nonverbal species is thinking. And this also establishes a basic framework. Hopefully this can keep growing in an open source way to encompass baselines for all sorts of different animals. Cats, dogs, birds, bees, of course they're hive animals, but you know what I mean? Like anything that's out in the wild, like pandas and tigers. It would be really interesting if we could start seeing like for a bear or something and like looking at it and being like, oh, it's agitated. I mean, not that we want to know that, but thinking about somebody on a safari or something, like looking at rhinos, knowing if they're peaceful or if it's time to like roll up the window or not. Maybe before it's too late and it's obvious to roll up the window, if you know what I mean. Or for like a veterinarian or for animal care or for training an animal. I just think there's a bunch of really unique ways this could be used. All right, now I don't feel like dogs have the ability to lie, although I know there's a ton of you who probably think different. I'm sure you've seen a dog that like did something wrong and then is like trying to cover its tracks. I don't know if that's really what's happening, but I can tell you there are new AI models that are built to lie to you. Let's talk about Meta, previously known as Facebook, for a second. And no, they didn't create just a model to lie to you, although you can kind of wonder with misinformation sometimes, you know? But they did create a specific AI agent, which they codenamed Cicero. And it was designed to play a specific board game called Diplomacy. And the way that whole game works is like negotiation and betrayal among players. They're kind of incentivized to sometimes lie, sometimes work together. So this game is playing that and learning to be superhuman. Now, Cicero is using a natural language processor, something that is earlier than the ChatGPT natural language LLMs, but it does also combine that with strategic reasoning, which enables it to communicate and strategize just like a human player when playing the game. And even though it's not human and it feels like a very human thing to lie and be strategic, it turns out that it got the top position in an online league, which demonstrates a significant advancement in AI's ability to understand and participate in complex human interactions. So think about that. That's social manipulation and collaboration to get to an end state. Not sure we should really have any AI that's really good at that, even though we obviously know it could be. And maybe that would help its owners in some way when it comes to negotiating, but I don't know, man. That's like weaponizing AI. It just seems stupid. To play this game, the AI had to understand aspects of bluffing, and it had to know when to empathize with other players to earn their trust. But I don't know, just a world where I don't really know if it's a human anymore, or if it's a superhuman or an AI that's on its way to being superhuman, negotiating, strategizing, befriending, betraying, just, oh my gosh. So that's where I'm gonna move on to using artificial intelligence for something much more mundane, much more nice, much more positive for the environment, which is beekeeping. Yep, that's right, we're talking about buzzing bees, beehives, beekeepers, all that stuff. This paper is called Semi-Supervised Audio Representation Learning for Modeling Beehive Strengths. This paper is talking about listening to the sounds that come from a beehive, or one of those big boards that beekeepers use that have the kind of fake beehive in it that you can slide out to get the honey. But the point is, it's a semi-supervised model that's listening to the environment to figure out if the bees are healthy or not. Which is interesting because you'd think, oh, maybe why isn't this like a camera vision thing? But it's invasive to like stick cameras in their environment. It's also a lot cheaper if all you have to do is set up microphones near beehives that are out there like naturally in the wild and not install cameras every time. And if you can get an accurate representation from the sound, why not just keep it simple? And I also found this paper really interesting because it's building on audio. And I mean, you know the sound, if you've ever been for a hike, of just the leaves blowing in the wind, the sound of like sticks breaking, the sound of the like birds chirping and rustling. There's probably patterns in there that are way beyond human comprehension that just tell you all sorts of information about how healthy the environment is, and if they're like the density of the trees is right, if there's enough pollen for everything that needs pollen in that area, or if there's, you know, animals and mammals that are like up in the trees. There's just something special about the sound of nature that I feel like AI could, you know, figure out. And look, what the jobs that bees do, that honeybees do, we all know is like one of the most important things for the ecosystem as a whole. I mean, these plants have to get pollinated, like it's essential, and bees are crucial to that cause. They are being decimated in so many ways, and the knock-on effects will probably catch up to us. If we have some tools that can help with that, where we can understand where it's the most serious, and I guess reinstall bees or something, and just bring some queens over and try to get that ecosystem back in balance, that might put out a small fire before it becomes a big fire. How about we talk about artificial intelligence models that do geometry? So we can thank Google's DeepMind for this project. It is called Alpha Geometry, which is an Olympiad level AI for geometry. And we are talking about geometry, the branch of mathematics. And this groundbreaking AI system is capable of solving some really hard gold medalist level geometry problems. I gotta admit, I was really surprised about this. I knew computer vision had some really good understanding of what was in an image, but there's something just about geometry problems that I really thought AI would struggle with. But Alpha Geometry has successfully solved 25 out of the 30 complex geometry problems from a benchmark set. But yeah, it seems like this neural model that they've come up with is able to sort of hone in. Like, it doesn't solve it in the same way you might solve an algebra problem, but because geometry is spatial and it has shapes and there is such an interesting mathematics to it, it's able to understand how to kind of hone in probabilistically on what the answer should look like, and then with high probability come up with an answer that is correct. In fact, in the blog, they argue that this method mirrors the collaborative process between like a rapid intuitive thought and then a slow methodical reasoning, which establishes an AI that can approach problems in a manner that's reminiscent of human problem solving. And I'm wondering if something like Alpha Geometry gets embedded into a model that's, say, flying a drone or something, that it might just be able to use the mechanics of a drone, like one of those little drones that can like zip around like a hummingbird and just angle itself perfectly through all these tiny holes, or just go at super fast speeds because it has a sense of geometry and it can almost like do the mathematics at a superhuman level instantly and angle itself around, or you know what I mean? Like, that's just gonna be, there just seems like a lot of ways you could integrate this into engineering problems or self-driving cars, real-world robotics that is going to actually make an impact. All right, now let's move on to the meta level of AI, and I'm not talking about the company. I'm literally talking about the word meta, meaning like stepping back from information about information, like, you know, epistemology type stuff, but for AI. To talk about this new model, thank you to NVIDIA, called Eureka. Okay, so Eureka is an AI model that's goal is to better train other AI models. That's what I mean by like it's like a meta model. So it's looking at how a model is tuned, what it's learning from, how its parameters are set on its initial data ingestion to actually try to improve that. That's what its reward signal is how well another system learns. So like a teacher to a student, it's the teacher assessing itself on when is the student learning the fastest, when is the student going from baselines to really smart, and how fast are you going, and the better that happens, the better of a teacher you are, so do more of the same. Normally we have AI researchers there that are like putting in data, they're trying different experiments to see how good something does, and they're the ones who are tuning the reward, trying to figure out how to get it to do better each time. But this system is now outperforming the humans 83% of the time of actually tuning the model, training the model, making decisions about how the model should look in the first place versus humans. So that's another just kind of like, okay, so like, at least as humans, we thought one of the last things that we'd be doing was designing AI, but no, AI is kind of now figuring out how to make its own AI better than us. Not writing its own code, although it could do that too, but we're talking about the even concept of knowing that AI in the world is there to do certain things and making sure that it does those things. But I mean, what can you say about NVIDIA? They're just knocking it out of the park. Look at this fake hand playing with a pencil. Like, it's optimizing that for us. Look at this robot navigating like the regular counters and drawers and cupboards that you would see in a house. Here it is optimizing the process of running. And it looks like it's doing kind of a good job, but that thing is moving. And the last interesting AI model I want to talk about is something I did just make a video on a couple days ago, but it's worth reiterating, which is the new Sora model that came from OpenAI. Now, in many ways, I'm considering this one of the most general, impressive models that I have ever seen, because although you would think of it as just video, because that's all it was trained on, the fact that it basically emerged its own sense of physics and object persistence in a three-dimensional environment without that information being explicitly put in makes it more that it figured out from video how to simulate everything in our real world in terms of how things move and who we are as people. And what I see from that is an implication that many other things might be pulled out of the video. Everything from our emotional state to potentially geometry, dog emotions, lying, archaeology, that all might emerge just from this concept of creating tokens that aren't just word fragments like ChatGPT uses, but tokens that are actually little chunks of video. And that is just maybe a really important step forward. Imagine a future version of Gemini does this to all of the billions and billions of hours of YouTube videos, which they're owned by Google. They have access to all of that information, and they might have the computational power, and they already have the videos on their servers to do this, and maybe even the rights to do it. That data set is so unique in the sense that real people have uploaded so much real information about their lives, who they are. You know, it's not Netflix. It's not really highly curated Instagram posts. There's tons of stuff on YouTube that's like very real. Like a lot of people put their home movies up there. And from that, it might really glimpse who we are in a way like even me and you don't. Like we don't go look at everybody else's home videos. We get like once in a while snapshots, and we do have real relationships that we're learning from. That makes us more human than a lot of these AIs because they're always looking at the online version of all of us. But I would say that there is enough, especially untitled stuff on YouTube or stuff that would be titled like the same name as like a video camera would title it. That stuff's not really meant to be consumed by the public. That's probably some real intimate, just like hanging out with friends kind of video that it's going to learn from. So who knows where the Sora model or something similar that comes out of Google in the future comes from. But yeah, AI for reality simulations from video is probably the most important type of model that I have ever seen. So my next goal is to get this channel to 10,000 subscribers. If you wouldn't mind hitting that subscribe button, it would mean the world to me. I'm gonna keep trying to make really awesome videos to help us all navigate AI one video at a time. And if you wanna be a Patreon of mine, that would be awesome. I only have a couple right now, but one of them, Rob, thank you so much. $100 a month means the world to me. That is by far where the majority of my YouTube income comes from. So thank you for supporting it. You're kind of like a sponsor actually, but you don't ask for anything. So you're not a sponsor technically, but thank you. I just appreciate you keeping the wheels moving on this bus. So see you in the next video.